Welcome to a video on combinations and permutations. We are going to focus mainly on combinations since you previously learned about permutations, but we will review what a permutation is very quickly. All right, so just to review, did order matter? Remember, when a group of objects or people are arranged in a certain order, the arrangement is called a permutation. Okay, so for example, if you were, if there was a race and you had, I don't know, 10 people racing and you were just giving out the first, second, and third place winners, how would you figure out? You would know that you have 10 options with 3 possible outcomes, so you would do a permutation. So in the calculator, we would write that in as 10 and then permutation 3, which we then could, if we were doing it longhand, we would go into here. So we would have 10 factorial, write it in the formula, and then we would have 10 minus 3 factorial. So remember, 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And in this case, 10 minus 3 factorial would be 7 factorial. So you would have 7 times 6 times 5 times 4 times 3 times 2 times 1. In this case, with canceling out, you would eventually get to just 10 times 9 times 8. Solve that and you would get how many different options you have for giving out those first, second, and third place winners. Okay, so how is a combination different from a permutation? In this case, order does not matter. For example, like in the lottery, it doesn't matter what order the numbers are on a lottery ticket, just as long as you have them, okay? So an arrangement or listing in which order is not important is called a combination, okay? And here is the formula. So you would access it in the same area as you would your calculator for the permutation, okay? The only difference is instead of picking the NPR, you would pick the NCR, okay? And I will show you an example of what that would look like both on the calculator and longhand, because you might come to a situation where you do not have a calculator with you. So here's our example. You need to write 4 book reports for your ELA class. Your teacher gives the class a list of 7 books from which to choose. How many different groups of 4 books can you choose from the list? Well, first off, we know that this is a combination because order is not important in this case. It does not matter whether you read Hunger Games first or Lord of the Rings first. Doesn't matter. Okay, so we know it has to be a combination. We need to find the number of ways you can choose 4 books from 7 options, which means that you would have 7 combination 4. Now, if you were to solve this longhand, which I'm going to show you how to do, it would be 7, the permutation 4 over 4 factorial. Okay, just like the formula that was on the screen before where you had NPR over R factorial. Okay, in this case, 7 is my N, 4 is my R, so I have NPR over r factorial, so then it would be 7p4. So if I were to figure that out, I would know that it's 7 times 6 times 5 times 4 all over 4 times 3 times 2 times 1. All right, now I can do one of two things. I can multiply 7 times 6 times 5 times 4 and then divide it by 4 times 3 times 2 times 1. But I'm going to pretend that I don't have access to a calculator right now. So I'm going to say I'm going to cancel out my 4's, and they're going to become 1's because 4 divided by 4 equals 1. Okay. I'm going to divide my 6 and my 3. My 3 is going to become 1 because 6 divided by 3 is 1, and or 6 divided by 3, sorry, is 2. So 2 is left up here. Now I can actually cancel out my 2's. So if I were to clean this up, I'm actually left with 7 times 1 times 5 times 1 over 1 times 1 times 1 times 1. In this case, that's much easier to solve, and that would equal 35. Okay. It is important for you to understand how to do this without a calculator because there may be a situation at some point in your math career where you don't have a calculator in front of you. Okay. Or, a test. So let's see how that looks with a calculator. Okay. So here is my online scientific calculator. Okay. I am going to type in my 7. I'm going to go to NCR here. On your calculators that we use in class, remember you have to click the PRB probability button and then click on NCR. NCR 4. I'm going to close my parentheses. If you can see up here, this is basically what I just solved, only just looking a little bit different. Hit equal 35. Got the same answer. Okay. All right. So what's the big difference? Just come back to the big difference between a combination and a permutation. Order matters for permutations, not for combinations. Okay. So just to drive that point home, determine whether each situation involves a permutation or a combination. This is very common of a question you may see on a quiz, test, homework, anything. In this case, there are 30 dogs in a dog show. Blue ribbons are always awarded to the top 3 dogs. How many different groups of dogs can receive blue ribbons? Well, it doesn't specify in what order the dogs are given the blue ribbons. So we are going to call this a combination. It doesn't say it has to be first, second, or third. It just says that they are awarded to the top 3. Okay? On the flip side, there are 30 runners in a cross-country race. How many different groups of runners can finish first, second, and third? This would be considered a permutation. Okay, so please come to class tomorrow knowing whether the difference between a permutation and a combination. Please know the formula for a combination and a permutation. All right, and we will go from there. All right, thanks.